Hey everyone, let's go ahead and talk about how to graph two variable inequalities. They're going to look like this. So if you're wondering what we're doing, we're going to be graphing two variable inequalities, the two variables, the x and the y, on a coordinate plane with three very basic steps. But I want to come back to one variable inequalities for one specific reason. As a reminder of what you do when you graph one variable inequalities, let's say x is greater than 2. You start with a dot either filled in or in this case open, and you shade in the direction of things that are true. Now your teachers might never have done this, but like one option is to pick a point that's not your circle. So your circle's at 2, so you pick anything that's not 2, like 0 or 1 or 3 or 4 or 5, and you try it to see what happens. So what I mean by that is, let's call this the TP, the test point. And if the test point is 0, you just put 0 in the x spot, and you write 0 is greater than 2, and then you evaluate that as either true or false. Now 0 is greater than 2, that's false. That means the test point is false, and that means that every other number on this side of my circle that I made is false, which of course means every other number on the other side are all true, which means my graph looks like this. Open circle at 2 and shading to the right? Now, if I have a second example, I should have had the line under here, so there we go. If I have a second example, x is less than or equal to 3. Here we go. I'm going to make my open circle at 3, and this time, because of that extra line underneath it, we're going to go ahead and fill in my circle, and we can use the same strategy again. I'll pick a different test point just for fun. I'll go ahead and pick a 1 as a test point TP. So let's try test point of 1, put a 1 in there, is less than or equal to 3, and that's either true or false. Now 1 is less than 3 is true, that means this is true, and that means everything else on the same side of that is true, and everything else is false on the other side, so I'm going to go ahead and graph in the direction of things that are true. So the theme here is that you make your initial mark, we'd call it a boundary, with your open circle or your closed circle. Open or closed has a meaning. You pick a test point, and then you graph in the direction of things that are true. So let's explore that exact same concept with two variable graphing with inequalities. Now, when I deal with two variable graphing and inequalities, the idea is that we essentially have to graph the line that we see here. So let's pretend for the sake of argument that we have y equals 2x plus 3 instead of y is greater than 2x plus 3. So plus 3 is 3 spaces up, and 2 is a slope of 2 over 1. So I'm going to go up 2 and right 1, up 2 and right 1, and I'll go down 2 and left 1, down 2 and left 1, and I'll kind of make some dots using that same sort of pattern. Now I have a note here, solid or dotted is not unlike the solid circle that we made or the open circle that we made in the previous slide. So I'm going to look at my inequality symbol. If it's a plain old greater than or less than symbol, we're going to keep the circle open or the line dotted or dashed. And if it's a solid line, which means it's greater than or equal to or less than or equal to, then we're going to go ahead and make our circle solid, which means our line would be solid. Now in this example, we have a greater than symbol, and the greater than symbol is right here. So we're going to go ahead and make this line dashed. So literally I'm just going to come in and we're going to make it a dashed line. That means that the line itself doesn't contain solutions, but it's a boundary line, just like the circle was. Now, with that in mind, let's go ahead and clear a couple things off. Oh, I got lots of overlapping writing here. So let's take a look at this next bit. Oops, when I try to erase things, I'm erasing what I had previously written. Oh, well. So let's go ahead and throw this in here. The second thing that you do is choose a test point that's not on the line. So just like what we did before, you can grab a test point. For example, the origin would be a great test point because it's not on the line. And we're going to go ahead and put the 0, 0 in your equation. So we're going to put 0 in the y spot, we're going to put 0 in the x spot, and we're going to figure out what happens when you evaluate this inequality. So 0 is greater than, let's see, 2 times 0 is 0, plus 3 is 3. And we decide, is it true or is it false? So 0 is bigger than 3, that's false. That means this test point is false. And that means every other point on this side of my blue dashed line is all false, which means all the points on this side are all true. So all we need to do is show off that all of this stuff in that upper left-hand section is all true. And to do that, very simple. If you have a highlighter tool, you grab a highlighter and you highlight this region. And you don't have to be perfect about it. You can be, of course, but you don't need to be. And there we go. That shows off the solutions, right? The solution is everything that's graphed. And if I grab this tool here, there you go, shade the true stuff. Now let's do one more if you need it. Maybe the second time through it'll go a little smoother. We have our same 3 steps as before. So we're going to graph the line and decide whether it's going to be solid or dashed. This time I'm not even going to change this symbol because I don't really look at it until I make the dots in the first place. So I have a y-intercept of 0. You'll know that because you don't see one. So let's grab blue and go ahead and make a dot. And I have a slope of -1/2, so I'm going to go down 1 and right to 2, down 1 and right 2. And I'll go the other way also, up 1 and left 2. And when I have a series of dots like this, now I have to decide solid or dashed. I see this piece right here, so I'm going to make my line solid. Literally, I'm just going to go ahead and make it solid. So I'm just going to grab a little bit thicker pen and make my line solid. There we go. Now I'm on step number 2, grab a test point not on the line. Now notice in this case, the origin would be a bad choice. The origin is on the line itself. So if I test that, it's going to say true because it's on the line and the line is solid, but that doesn't help me know, do I shade up here or do I shade down here? So I'm going to grab an equally easy test point. I'm going to grab this point right here. That test point's really easy to identify. It's 0.11. And let's plug it in and see what happens. So I'm going to put a 1 in the y, and I'm going to put a 1 times in the x. All right, so I have 1 is less than or equal to -1/2, and now I decide true or false. So 1 is smaller than or equal to -1/2. That's false. That means the test point and everything on the same side is false, which means I have the true stuff down here. I'm going to shade all the true stuff. And that is how you graph 2 variable inequalities.